I have other creepy podcast information I realized.
Oh, okay. More creepiness.
Yeah. I'm listening to some CBC podcasts. So for the people who doesn't know, CBC is like the English version of the public broadcaster in Canada. But we are both in Quebec, which is a French province. Like the one thing weird I realized that every ad I have in the podcast is from the Gouvernement du Québec.
Okay, so I noticed the same thing.
So this means that they're tracking us and serving us. Yes, because on the CBC, yes, because on the website, it's not the same ads.
That's conspiracy bacon right there.
Let's
No
do
way.
it right now.
Impossible.
Okay, what's the podcast I'm listening on CBC?
Is it Front Burner?
Yes.
Okay, yeah, that's the one. I listened to that one too. They're like Atom feeds for podcasts and whatnot. Like you have one file and one entry.
But they don't need to. Okay, I think they removed the ads on the website.
I don't know. I always assumed that like the Quebec government sponsored, like bought an ad.
Yeah, the first time
generally relevant to the country.
Look, the first time I heard one, I said the same thing. But after like 100 episodes, I'm like, no, there's no chance that every single episode of every single CBC podcast I'm listening to are from Quebec.
I just assumed that like the Quebec government was like hip and with the times and bought ads in a national podcast that people listen to. And it's like a message that's generally applicable across the country anyway.
Okay, you know what? For this episode, we'll stop there. Next episode, I'll do my research.
There will definitely be a follow-up.
Let me buy like some compute time on GCS to download an episode from there to see what I get.
Yeah, hey, that's a great idea, actually. But I mean, I still don't get how they would dynamically serve it.
I have another example. So I'm listening to that podcast. What's the name? Darknet Diary.
Oh, okay.
And it's an American podcast. And I always have Canadian ads. Every single time.
I don't know. It could be happenstance. I don't know. I always just assumed that podcasts were a singular file.
Yeah, me too.
That is delivered over a singular stream, like an RSS feed.
Yes, but you can still change the content by IP, by request IP.
Oh, okay. So you're saying like wherever the file is hosted,
they cheat you.
It will. Okay, I see. Okay, then maybe it's not such conspiracy bacon, but I don't know. I mean, I guess it's possible. But yeah, we'll find out next week.
Yeah. On conspiracytheory.com.
Yeah, exactly. Yeah, like I said, if you had a YouTube channel, it would be banned by now.
It's sad because you're probably right.
Yeah.
Welcome to Randomly Typed. I'm JS.
I am Lance. So JS.
Yes?
Do you remember what you were doing on July 2nd, 2019?
I don't even remember my birthday date, so there's no chance I could remember that.
What did you eat for breakfast, though?
Yeah, I don't know what I ate this morning.
Nothing? I could tell you I had 2 delicious pieces of toast with peanut butter and blueberry jam.
Ooh, okay, I lied. I ate some oatmeals. That was pretty good.
Okay.
With like mango.
Yeah, oatmeal. Oh, mango.
Yeah.
I'm not the biggest mango fan, but...
Really? One of the
I
best
don't know,
fruits.
Blackberries and cereal. That's what I'm all about.
I prefer like blueberries.
Blueberries are also very solid, yeah. Blueberry jam, that's where it's at.
Oh, yeah. Yeah, I agree.
So what happened on July 2nd was that basically the internet was down for 30-ish minutes, maybe 60 minutes. I guess it must have been like a gradient of when it was slowly degrading and slowly recovering. Do you have any recollection of that?
None.
All right, so I'll be more specific. What happened was, this was I'm talking about a Cloudflare incident, actually, and it's a pretty well-known incident because they published this awesome blog post that we'll link to in the show notes that talks about what happened, and they were very, very transparent. The issue and the response, and they gave all the tools and flows that they normally go through in their deploy process. So I think this incident was super interesting because of, one, the scale, and two, the response of the company and the problem itself. Like, what actually caused the incident was also pretty, I wouldn't say funny, but it's something I could totally imagine myself doing.
Yeah. But it's crazy when we think about it, because Cloudflare is the internet. Like,
nowadays,
12 years ago, something, they were pretty much not there. And now, like, what? I guess they're like running half of the internet. Something
yeah,
like that?
I know a lot of people that are apprehensive about it, even though Cloudflare is like showing all signs of being on the good side of things, if you know what I mean. I guess it's just the like anti-monopoly instinct in us is like, ooh, this is getting really big, even if it seems like a good thing. Yeah. It's a lot of responsibility.
They look like nice people. Like, they have a good track record.
That's the thing. They do have a good track record, but for all the folks who are worried, say, like, for now, right? You don't know what they'll do in the future.
Yeah. I think a good example is like Google. Like, don't be evil. And okay, let's not go there, but you know what I mean.
Yeah. Yeah, like, we'll skip right over that. So what happened was basically all traffic on the Cloudflare network worldwide ground to a halt. What users saw was that pretty much every browser request came back as being a 502 at that gateway for virtually every site for about 30 to 60 minutes. So this was pretty impactful. So what happened was, I guess, like, this affected what they call their web application firewall. Do you know what that is?
So I guess it's like intrusion detection, like trying to filter bad requests and shit like that.
It's exactly that. Yeah. So it is a reverse proxy of sort. So it sits on the edge and takes incoming HTTP requests and analyzes them based off a bunch of rules, and they call them policies. And if it seems like this might be someone trying to exploit something, they'll just block it before it even reaches the application server.
So this means that they need to have access to the TLS keys, right?
Yes. So HTTPS. Yeah. I don't know exactly how they do this, but all I know is that they have their own walls in Lua, and they take a bunch of rules and they apply them. And there were like almost 4,000 of these rules in the form of regexes.
What could go wrong?
So regex for HTTP requests that look fishy. And the goal was really to protect from attacks like SQL injection or stuff like that, right? And this is all at the application layer. So this is all over HTTP that this is happening. So what happened that day was that there was a, in quote, minor fix
minor
that was deployed to a single rule. So a single web application firewall rule, which was trying to change a regular expression that was trying to detect cross-site scripting. The TLDR of that is cross-site scripting is when an attacker is trying to make other people see their malicious script on a like trusted service, right? Like it's somebody injecting a script so that other folks can see it when they shouldn't. So that's something that Cloudflare would want to try to protect their users from. And so they have rules for it in the form of regexes. And what happens was a bad regex, in quote, was shipped. Go check out the blog post. There's the actual regular expression there in the blog post. And it looks very innocent. That's why I mentioned I could totally imagine causing this incident. So after this was deployed, all CPUs on all machines that handle HTTP and HTTP traffic on the Cloudflare network, all CPUs were exhausted, and it basically had no more processing power.
That's simple.
Do you have an idea of what might have happened? Like, why did this take place? Like, why did a simple change to a regex have such a big unintended effect?
Like, really simple things can break your whole system. So normally, like when your regex explode in like some exponential complexity, and sometimes like the rule doesn't look like it should, but it does.
Yeah. So in this case, it was something called backtracking, which is exactly that. You end up with an exponential computational complexity for this regex by accident, and it's super easy to do. So that's the cause. We'll get more to that later because there's some interest. Like we'll go into like exactly what backtracking is and like exactly what caused this incident after. But for now, I guess I'll keep going with the description of what happened and how it did happen, right? Because that's a huge thing to happen for an in quote minor fix. Like they explain that normally their changes go through a super slow deployment process across multiple stages to make sure that everything, like nothing will break. But web application firewalls usually need to adapt quickly to like new CVEs and new vulnerabilities that happen in the wild. And so for this one part of Cloudflare, they just have basically, they have some tests, of course, and they have checks. But there is a way to just deploy this thing and have it be live in seconds.
So like you skip like canaries and things like that.
Yeah, exactly. What's funny too is that they actually did the due diligence of deploying this within seconds, but in a simulation mode, where it doesn't actually affect real traffic. Like it intercepts real traffic, but it'll never block anything.
Okay.
Just to check like whether this rule is actually accurate or not, or whether there are more like false positives or unintended consequences of deploying this thing, which is like super savvy, right? It's like a great way to do things. But unfortunately, even when you're simulating things, you need to compute regexes. So like that didn't really help.
That's so funny.
You still need to actually run the regex.
That's so good.
So what's even like more unfortunate is that they actually did have a CPU exhaustiveness check in that web application firewall, and it was accidentally removed a couple weeks prior in some refactor. Yeah, I know.
So unlucky.
Oof. It's very, very unlucky. My hearts go out to Cloudflare. My heart's lull. My heart goes out to Cloudflare employees that day. That like series of unfortunate events that happened for this to happen. So they were able to roll back, but they had issues because most of the internet was down, including their own systems. And so accessing them was hard.
No.
And a bunch of security credentials had expired at the same time. And so that getting new ones was really hard too.
Serious? Wow.
Yeah, I know. Isn't it? Like, it's just everything was July 2nd, 2019 was, a rough day. So the resolution was to like add those checks back, manually inspected all of the rules afterwards for this backtracking, and they planned on switching to a different regex engine, which did not support this backtracking.
Because I know most old engines don't have backtracking. I think it's like hair quote like a new feature for regexes.
Oh, really? I was under the opposite impression. I know all the new regexes don't include it because it's so dangerous. But you could be totally right. I'm definitely not the expert here. And now that I've said that I'm not the expert, let's go into the details of what backtracking is and the example, like this actual example, which caused the incident. The Lua firewall they were using used PCRE, which is Perl compatible regex expressions, which is a very common regex engine.
It's probably the one we see pretty much everywhere.
Yeah, it's the one that I see the most often. But that's the thing, there are different ones with different guarantees. Some regex engines will support some features like backtracking, others will not, for performance reasons and also for guarantees. So like PCRE has no computational complexity guarantees for an arbitrary regex. Like it could just run indefinitely.
Oh, so now that you mentioned that, so RibGrep, I know don't support those by default.
That's exactly what
because they want to have.
That's exactly what I was thinking.
They want to be fast.
Yeah, and at least have a guarantee that it'll finish in a non-exponential time. But some of them might not even finish at all. Let's talk about a formal language theory and language classes in a different episode, because this is super interesting. Like, there's decidability is a problem too, where it's like, will it ever finish? So let's talk about that a different time. So backtracking itself. Okay, we're going to go through an example. I'll keep it short, and it might be a little hard to visualize. So just close your eyes wherever you are, listener, and try to visualize this. And also warning that I'm not a regex regular expression engine, so it might compute things slightly differently, but the intuition is there. The regex pattern that they asked for was in the incident was dot star, an equal sign, a literal equal sign, and then dot star.
That's so simple.
Right. I know. It's super simple, which is why it's like super unexpected that it would cost something like that.
And there's backtracking here?
Yeah. So what happened was like, so when you say dot star, it matches 0 or more characters, but greedily. So it'll try to match as many as possible. As much of the test case string as possible, it'll try to, at first, match as much of it as possible. So let's pretend we had this string x equals x. It matches dot star, which is 0 or many, and then an equal, and then 0 many. But that takes 23 steps to confirm a match. The reason why is that like the first dot star is greedy, so it'll attempt to match the entire string. So it says, okay, the entire string is matched. And then the second dot star goes, and it's like, oh, well, I have nothing left to match, but that's okay because I still have like nothing. Like it's okay if I match nothing because dot star is 0 or more. And then it gets to the equal, and it's like, oh, crap, I can't match it. Like it was already matched in the first dot star. So what it needs to do is backtrack all the way back to the beginning of that first dot star. And instead of taking the entire string, it'll try to take one less character. So it'll be like, okay, well, now let's try doing x equal. And it's like, okay, cool, that matches. So the next dot star can match the last x on the end. And it's like, okay, that works for me too. They're both greedy, so they both try to match as much as possible. And then again, the equals can't be matched because the entire front of the string took everything. So it needs to backtrack again to the first part and then repeat indefinitely, basically. What's worse is, as you mentioned, it's exponential. So like x equals x takes 23 steps. X equals xxx takes 45 steps. And if you have 20 x's, it takes 555 steps. Oof. So it's exponential growth here.
Yeah, that's bad.
Yeah, it is. So the fact that this backtracking happens is basically why it has no complexity guarantees, PCRE. Like the fact that they allow this means that you can never be sure how long it'll take. There is a way to make matches lazy instead of greedy, but even still, it with regexes are hard. It's except for ripgrep or all the fancy ones with like a much more minimal feature set. Complexity, like having a guarantee that a regex will run in a certain time is something that's very hard to do.
So I guess it's impossible with like all the features. So you need to disable the features to have any guarantees, right?
Right. So the only real solution to this problem is to rewrite your regex to not use these features or disable them or use a different engine which doesn't support these features. The only problem though is that having things like this greediness and backtracking lets you solve a bigger class of problems than not. So sometimes the only solution is to rewrite your regex, but that means you can't express the regex you want anymore.
So it's less powerful. So that's what you're saying.
It is. Yeah, it is less. Like the fewer features you have in your regex engine means the less power, the less you can express in a language.
Right.
If everyone wants a take-home exercise, try to write a regex which matches all even length strings where the first half is A's and the second half are B's. Please try to do this at home. And please let us know if you find a solution. And we'll take all the credit for the paper we'll publish because this is not possible.
That sounds simple. Is the problem because like the even part?
Yeah. It's the same number of matching. It's the fact that you need, like if you have AABB, that you need to guarantee that it's like 2 A's and 2 B's, or that it's 3 A's and 3 B's, but it's like that N needs to match.
So what you're saying is that regexes cannot represent every string.
No, so like that one, it like that language, so that like that set of strings that consists of this language, which is like AB, AABB, AAA, BBB to infinity, you cannot do this with a regex. You need to use something like a grammar and parse it. So yeah, that's all I had for this incident. Such a tiny little regex incident and so much learning taken out of it.
Okay, so I also have a quick one for you. Because like
nice. Oh, was mine quick?
Nope. So we're now at 26 minutes. So, nope.
Oh, nice.
Yeah, 2 weeks ago when we were talking about that, I thought we were talking about the same incident, but we were not. I guess it's really easy to break some regexes.
Yeah, I don't doubt it. Have you, like, every time I look at a regex, I suddenly, like, forget everything I know.
So I'm good to do, like, easy regex, but when it starts to be complicated, it makes no sense.
And the fact that they're like different standards and different engines makes it like even more complicated.
Okay. So I wanted to talk about the Stack Overflow incident, which was in July 2016.
Ooh, earlier.
Yes. And so Stack Overflow was down for 34 minutes, which is a little bit less bad, but
even still though, like even an hour, like I've heard of incidents that lasted for days. You know what I mean? Like that's fast. Like 30 minutes is pretty fast to identify.
Yeah.
Like
it's crazy.
And ship. Yeah, that's fast.
The number of like incident I was on and took like hours just to understand the thing.
Yeah, same.
And like after like 1 hour to deploy the fix, like 34 minutes is so good.
Yeah.
So they also wrote a blog post, but it was pretty bad. And like it was too simple, but still. They wrote that it took 10 minutes to identify the problem. So 10 minutes, that's so good.
That's really fast, yeah.
14 minutes to write the fix.
or did it take 10 minutes to get paged?
Yeah.
No, they wrote, you said identify the cause. So yeah, that's unbelievably fast.
Yeah. So their tooling has to be so good.
Yeah. Or it must have happened
every week
immediately after a deploy.
Oh, yeah.
Like it must have not been like it must have been obvious what it was.
So no, it's
right?
not. That's why it's interesting. So I'll come back to that.
Okay, cool.
And 10 minutes to find, 14 to fix, 10 to deploy. Like 10 minutes to deploy.
Wow. I know. That's what a world.
Yeah.
Like
So maybe they don't have any test or they just skipped CI. I'm not sure.
Yeah, probably an emergency deploy. Yeah.
The issue was triggered by a new post on Stack Overflow, not by an update. So that's interesting. So it's like the inverse of your incident. They couldn't like look at like, oh, that regex we just pushed crashed the internet. It's just like, oh, for some reason Stack Overflow is down. The post was play happy sounds for a player to enjoy, roughly 2,000 spaces and something else at the end. What could go wrong, right?
That's hilarious.
So they had the regex to like cut trailing white spaces. And the regex,
no.
Yeah, exactly. So the regex was something like \s plus $. So this means like \s is like any white space.
Yep.
Plus is like 1 to infinity. At least one, yeah. And $sign represent the end of the string. Find all the thing at the end. What happened is that the regex engine look at the beginning, which is like play happy sounds for a player to enjoy. Good, we don't care about this. 1 space, good. 2 space, good. 3 space, good. Continue until the end. Well, just before when there's like something else that is not a space or the end of the string, which they didn't say what it was in their blog post, but let's say it's A. So it finds A. So it's not a space and it's not the end of the line. So they start again, the same thing, but at the second space rather than at the first space.
Oh, no.
So now they did like 20,000 execution of like, yo, is it a space or end of line? And afterward, they do the same thing, like, but once less.
Yeah.
So it's, so in their
N squared.
No, it's, well, okay, that's what they said in their blog post, but it's not N square. It's, what's the thing in math, like N bang?
Yeah, but it's still N squared though.
Yeah, it's close to square because it's a little bit less than square. Yeah, because factorial is a little bit less than square.
But yeah, us computer scientists too lazy to they're like factorial, nah, square.
Same thing.
That's easy.
Yeah. So yeah, that's how Stack Overflow was down for 34 minutes.
So it was a single post?
Yes, a single post. And that single post was on the homepage.
It was processed once?
No. It was on the homepage.
It was on the homepage. And they run the regex every time?
Yep. Because like to not show the white
gosh.
space like in the description or something. I don't know.
Oh, that makes sense. Oh, you gotta wonder, this person who wrote play happy sound for player to enjoy, whether they knew what they were doing or not.
Yeah. And it's funny, like in one of the comment of the issues, like, yo, you crashed Stack Overflow.
Oh, I wonder, it must still be up.
Yeah, but I think they trimmed the thing.
I know, but it's still, we can link to it.
Oh yeah.
If we can find it.
Okay, I'll link to it in the show note.
Do you have the link to the issue?
No, but I know where to find it. Because initially in the blog post, Stack Overflow didn't mention who it was, but someone on Reddit think they found it. So
you're right. I'm at the blog post now. It is so tiny.
Yeah, I'm pretty sure they trimmed it.
So little information. Yeah, they trimmed it.
Yeah, their blog post is not... Well, at least they did one blog post, which is cool, but...
Yeah, which is nice. But yeah, definitely check out the Cloudflare one. It has a bunch of details. It's really, really, really well done.
So I guess that's what we have for this episode.
That's right. What's the takeaway?
Don't...
Regexes are hard to understand.
Yeah, like don't regex. If you can not do it, don't do it.
Yeah. It's like if ever, what's that like? There's always that trope in software where it's like, if you think you can solve a problem with regex, now you just have two problems.
Yep.
Yeah.
But honestly, they're super powerful, and there's so many things. I wouldn't see myself use something else, but still.
Have you ever played that regex crossword game?
No, but on my cégep, like Regex Golf was like the big thing.
Yeah, of course. Yeah, here, let me link to the regex crossword. Really fun, actually. It's like a puzzle game, but with regex, and it's like it ramps you up. So if you're trying to get used to regexes, if you're just learning, definitely check out this resource.
Cool. You know what? We should do an episode at some point about why the engine cannot stop by itself, or like not know that it will bring down the internet, like the complexity.
So let's do that in the formal languages one,
exactly.
because it's very much related. We'll maybe try to do that for the next one, but we'll see. We'll see about that.
Yeah.
No guarantees.
Preparing episodes is hard, so you know.
Yeah. And that one's definitely not trivial either. So
yeah,
cool. Well, thanks, Jess. This was fun.
Thanks, Lance. See you next time. Yes.
Alrighty, bye.
This podcast is both free and free, as it's distributed under the Creative Commons.
You can contact us and find show notes on our website, randomlytyped.com.
The intro music is by Vansky.
Thank you, Vansky.
And thank you, listener, for indulging us.